My full names are Ernest Mwaba. I'm a trainer. I teach my students in automotive electronics and also heavy equipment electronics. I'm going to do a demo that will bring out the logic gates, the main ones that we handle. If we say this is an AND gate, how does it behave? Because we always have those symbols and those illustrative circuits we make. But we want to see a demo using Locktronic boards, which are specifically meant for this task. And I'll straight away try to transition so that first of all, I'll introduce each of them one by one. Here are my components. Starting with what we call an AND gate. AND means that you need two people for something to happen. In this case, we need A and B. So this is my input A and input B. For us to have an output which should be true, which should be 1, or to have an output where we have this to be on, both of them should have a voltage. If you put 0 there, then you put some voltage there, then nothing will work out here. So that's an AND gate. This is the symbol. Now moving out from an AND gate, we have an OR. OR gate means either A or B. If A is at logic level 1 and B is at 0, your output will still be 1 because this is either A or B. But if you put zeros on both of them, then the output will be 0. Now this being an OR gate and this being an AND gate, they take us to one other interesting logic gate, which is known as a NOT gate. A NOT gate negates, meaning if I put 1, I'll get a 0 on the other end. If I put 0, then I'll get 1 on the output. In other words, if we have a voltage or some current flows through there, here we'll have nothing. So that is a NOT gate. Now in electronics, we don't end here. We also cross over where we can now mix this one with this one. If I add an AND gate and a NOT gate, what I have is a NAND gate, which is this one, a combination of an AND gate and a NOT gate. Now, if you notice, a NOT gate has something very distinct. You will notice there is a circle right in front of that triangle. This is a special feature which simply identifies that this is now dealing with a NOT gate. So the moment you see this is basically our circuit symbol for an AND gate, except there is this small circle here, that small dot there. This is the one which tells us that we are now dealing with a NAND gate, N-A-N-D. Meaning that what we expect with an AND gate, here things are exactly in the opposite. Now what do we do from there? We also have another one, which is now combining an OR gate and a NOT gate. So now you have NOR, a NOR gate. With this one, we said as long as you have one of the inputs at logic level 1, in other words, you push a voltage on A or B, you will still have an output there. It will be turned on, or you have 1. Or you put both of them, give them a voltage, you still have 1. These one things are opposite. It will almost end up behaving like an AND gate, meaning what we're expecting here, just flipping it around, and this is what we have. So NOT plus OR, this is what we have. So these are the components.